James, I'm not I'm only familiar with the rudiments of physics. I'm basically an economist and a monetary theorist, but I struggle with the problem of definitions, and I want to ask you to what extent uh, the problem of defining your terms in physics leads to misunderstanding and bad communication. It is a real huge problem in economics. I mean,
Mm.
I run into it and it's so frustrating because I guess I have to give an example. The Fed defines inflation as an increase in the consumer price index.
Uh-huh.
That absolutely makes no sense. There's so many because if a definition is the differentiation of if a definition differentiates the concept you're defining in its most fundamental sense, then mere price increases have nothing to do with fundamentality. I mean, it's
Mm.
just
Hmm.
nonsensical.
You would
So
conceptualize it as an expansion of the money supply, right?
yes, an increase in the
Yeah.
best definition, and I'm open to changes on this always, but the best definition I know of is an increase in the quantity of money caused by government action, which an almost equivalent definition is an increase in the quantity of an unproductive increase in the quantity of money.
Mm. So if they mined a bunch of gold one day, if suddenly we discovered a ton of gold and we had a gold standard, and then the price of everything in gold suddenly went way down. Oh wait, that would cause the price to go. No, no, that would
What
cause the
about
prices to
an
go up.
aluminum
It caused the
standard,
price to
for
go up.
example?
Yeah.
Yeah, it would cause. So
Aluminum
you
used to be
wouldn't
very, very
define that as
expensive.
inflation.
No, because
It doesn't seem to
resources,
work.
no, because resources would be dedicated to mining the gold and so forth. So it would be gold would be mined on the same, it would be produced on the same basis as anything else being produced. But
I
so
mean, it would just be a change in the relative value of different
yeah,
goods.
but right, and so prices can change, and increases in prices don't mean inflation. But prices can increase, and it doesn't have to be what we commonly think of as an inflationary experience. I mean, you can have a hurricane that causes prices to go up, and now you actually
Right.
have economists saying, "Oh yeah, hurricanes cause inflation." Well, that's just nonsense. That makes the whole idea of inflation completely nonsensical and arbitrary. So
Yeah.
I don't want to get, I'm not trying to get stuck on a discussion of inflation. My point is that the problem of defining terms is a real issue. And people talk, it's not just that people talk past each other, people just don't even know what they're talking about. And
Yeah.
to what extent is this a problem in physics? I'm trying to determine if this is a problem that's mostly confined to the so-called social sciences, or if it's also a problem in all science or in all quests for knowledge.
Um, this is a really great question, and there is a reason that I allowed us to go a little bit into the details of economics there because I want to go into an epistemological aspect of all of this that I think is really important. First, to answer your question, though, it's not nearly as bad. Physics is the concepts in physics, and I'm going to focus on concepts here, not their definitions, and I'll get back to why later. But the concepts in physics are very tightly formulated. They're not perfect. You do sometimes get this kind of shenaniganry that you're talking about, where we have bad definitions, people talking past each other, stuff like that. But it's way rarer. It's way rarer, especially when you go back to the basics. Like the as far as I know, all the concepts around Newtonian mechanics are just beautiful. They're just perfect. They're people know exactly what they're talking about when they talk about mechanics. I think when you start getting into territories that are corrupted, like places where the ether gets rejected, you start getting people start saying things like the field contains energy. And that, that's a problem because the field isn't an entity. So how does it contain a thing? How does it have this property? What they really mean there is that the ether has energy and that you can relate the quantity of energy that the ether has to the field that the ether has at that particular location. There's a legitimate mathematical relationship between energy and field. But there's this slight mistake there, but it ends up being important when you say that the field has energy or the field has momentum. You're attributing a property that properly belongs to an entity. You're attributing it to a non-entity, a field, and a field is a capacity. It's not an entity. It's a kind of property. So we get these mistakes as we go further, but yeah, it's not nearly as bad.